Two of the quantities you see up on the board right now are vectors, and one of them is a scalar. Tell me quickly, real quickly, which ones are the vectors? Yep. Good. Position and displacement are vectors, and of course, distance is our scalar. How do we define position? Andres? Yeah, it's where something is. How do we define displacement? Matt? Yeah, the change in where something is, or the change in position. We could say it's delta D, right? If the symbol for position is D with the arrow over it, got the arrow because it's a vector, right? Then displacement would be delta D with the arrow over it. Units for both of them, the standard units are going to be meters, as well as the standard units for distance are going to be meters as well. Now, there's a couple of ways that we can find displacement. And this is what the whole worksheet that we did yesterday was based on, finding displacement. What's one of the ways of finding displacement? If we're given displacements, right? If we say guy walks 10 meters, then he walks another 20 meters, how are we going to find the displacement there, Ethan? Right, we add displacements. Remember, displacements, add. What's the other way? If we've got positions, which is where we are at a couple different moments in time, how are we going to find displacement then? Right, subtract them. So we're going to say the final minus the initial. Some people think it's always the bigger one minus the smaller one, or the north one minus the south one, or whatever the case may be. No, it's the final one minus the initial. So where you are at the end of the problem, subtract where you are at the beginning of the problem. Sometimes that gives us a negative number, a negative value. That's okay. Sometimes we want a negative value for the displacement. All right. We'll do a little bit more review in a few minutes, but the first, before we do that, the rest of the review, we'll take a look at the worksheet that you had assigned for today. And we had 3 questions on that worksheet that we wanted to go over, questions 6, 7, and 8, starting with number 6. It says a woman begins her driving her car 200 kilometers north of Calgary. Sometime later, her car is 100 kilometers south of Calgary. What's the distance traveled, and what's the displacement of the woman in the car? What do we got given to us here? Are these positions, or are these displacements that we have given to us? They're positions, right? When we have a reference point, that was one of the questions in your check and reflect questions, right, out of your textbook. What's the purpose of that reference point? When we have a reference point, it's going to be position. We have to define position relative to something. Displacement, we don't. So when we see 200 kilometers north of Calgary, not just 200 kilometers north, it's going to be position. My initial position, and this is going to be my final position. We're going to make this one positive because it's north, and we're probably going to make this one negative because it's south. Let's get displacement first. Honestly, for whatever reason, even though displacement involves directions and sometimes involves positives and negatives, I actually find it easier to find than distance. So let's do that first. My displacement is the final minus the initial. The final is negative 100. The initial is positive 200. Why did we put the negative in there if we said positive 200? Yep. Yeah, not because it's position, no, Brennan? No, the 200 is north. Why do we put the negative sign in there, despite the fact that the 200 is north? Right, it's df minus di. So we're subtracting a positive number there. We can't just say negative 100 plus 200. Okay? It's negative 100 minus positive 200. That works out to be, by the way, negative 300 kilometers, or 300 kilometers to the south. Now, what's the distance covered here? What do we know about distance and displacement whenever we're not changing direction? They will always be the same. Good. So if the displacement is negative 300, the distance traveled is just going to be 300 kilometers because we're not changing direction. That's a bit confusing, right? It looks like we are changing direction, north and south. No, that's not changing direction. We're going south. We didn't turn around and go south. We've always been going south in this problem, so distance and displacement will be the same number. 7, a boy walks 100 north, 200 east, 50 south, 200 west, and 50 south. What's the distance traveled? What's the displacement? This is the one that I'd probably say distance is easier. What are we going to do? Add them up. We don't care about north, south, east, or west. We're just going to say 100 plus 200 plus 50 plus 200 plus 50 ends up giving me 600, is that? 600 meters, and there's no direction associated with that because it's a scalar, right? What about the boys' displacement? What about the boys' displacement? The change in position? This is a vector, right? This is a vector. We need to account for direction here. Now, it's a bit tricky because we've got the north-south, but we've also got the east-west in the same question. My suggestion here would be to kind of look at the north-south together and the east-west together. 100 meters north, 50 meters south, 50 meters south. Those are all displacements, right? 100 plus neg 50 plus neg 50 gives me 0. 0 north-south. Let's look at east-west now. 200 plus negative 200 gives me 0. So the east-west is 0 as well. What's the displacement? 0. I'm back where I started. Back where I started. It's kind of a crazy path to get there, but back where I started. Yep. Yeah, they cancel each other out. That's exactly what happens. Yeah. When you add 200 plus negative 200, in effect, it's canceling out. Yeah. On finally, number 8 says a man begins driving his car 50 kilometers east of Banff. A little while later, he's 300 kilometers east of Banff, and even later, he's 400 kilometers east of Banff. Let's get to displacement again. Let's go displacement first. These are, by the way, positions, right? Displacement is the final position minus the initial position. It's going to be, what, 400 minus 50? Where does that 300 come into play there? Two-word answer. Where does the 300 come into play, Andres? It doesn't. It doesn't come into play. It doesn't matter how we get there. What matters is that we started here, we end right here. So it's just going to be 400 minus 50 or 350 kilometers. East, right? Because positive is east. What's the distance traveled? Well, we didn't change direction. So the distance is going to be the same as the displacement, isn't it? It's going to be 350 kilometers. You guys feel good enough for that stuff to ace tomorrow's quiz? Good. Second set of homework that you had last night was based on page 10, questions 1 to 7. Let's take a look at those ones now. Let's take a look at number 5. A person's displacement is 50 kilometers to the west. What's his final position if he started at 5 kilometers to the east? It's a little bit different. Let's define east as positive. What do you got given to you here? His displacement is 50 kilometers west. That would be delta D, right? We'll make it negative, though. What about this one? And what's his final position if he started at 5 kilometers east? That would be DI, right? And we're looking for DF. Let's say delta D is equal to DF minus DI. And let's solve for DF. How do you do that? How do you take the DI to the other side? DF minus DI goes to the other side by, right. So delta D plus DI equals DF. We're going to say delta D is neg 50 plus 5 gives me negative 45 kilometers, or 45 to the west. Good. If you understand all 7 of those questions, and if you understand all 9 of the questions on the worksheet, You should be good for tomorrow's quiz. Okay?